Classification of auxiliary views. Classification of auxiliary views. Auxiliary views are named for the principal dimension shown in the auxiliary views, such as depth auxiliary, height auxiliary, width auxiliary. Depth auxiliary views. The inclined surface will appear foreshortened in a top view and right side view. Height auxiliary views. A height auxiliary view projected from the top view and height dimensions is true length. Width auxiliary views. A width auxiliary view is projected from the profile view and the width dimension is shown true length. So I'm gonna show how to project a classification of auxiliary which is auxiliary views, which is depth, height, and width. So the first is getting to know reference plane. Instead of using one plane of projection, reference planes parallel to the plane of projection and touching or cutting through the object are used in auxiliary views. Reference plane should be positioned so it's convenient to transfer distance. Reference lines, folding lines, are always at right angles to projection lines between the views. Measurements are always made at right angles to the reference line or parallel to the projection line. In the auxiliary views, all points are the same distance from the reference line as the corresponding points are, for, are from the reference line in the alternative view or the second previous view. Reference plane. A reference plane on the side. B is symmetrical auxiliary view and C is non-symmetrical auxiliary view. Hidden lines in auxiliary views. Generally, hidden lines should be omitted in auxiliary views unless they needed to clearly communicate the drawing intent. Getting started. Examine the views or choose the plane to project in its edge. Draw reference fold line parallel to the edge view, the inclined surface and its convenient distance from it. In the front view, draw a light construction line at right angles to the inclined surface. From all points in the front view, draw projection line at right angles to the inclined surface. Next is transfer depth dimension. Use the adjacent view to visualize where is darkened final lines. And the last, use the projected length and depth via adjustment. View determine the true size and shape of the object. So, starting by the surface, will be projecting an edge form. This is the true length. So, ito yung figure. Start by determining the surface that needs the projecting in edges view. Then create a reference fold line. This line can be used to start auxiliary views. Remember to create the line in an open area where the ended view will not conflict with other views. So this is the surface of an edge and view, and this create a reference line that is a parallel to the projecting edge. From the reference line, measure over the needed widths. Remember the lengths are already determined by the projection line. Using the measurement from the adjacent view from the reference line, measure 0.52 draw at construction line. Then do the same for 1.12, 1.42 and the overviews with line at 1.80. This is not proper technique. It's proper technique. It's just to show that our size and shape are verified. So this is the finished product, a figure. So this is the review. This is the object. Step 1, the top front view and side. This is the step by step.